Hi students, exercise 9.1. Sketch the graph of function, that is f, then identify the values of x0 for which limit x approaches to x0 f of x exists. Okay, uh, it means f of x exists, find the value of x0. Okay, find the value of x0, that is limit. Okay, question number 17, f of x equal to sin x, x less than 0, 1 minus cos x, 0 less than or equal to x less than or equal to pi, cos x, x greater than pi. Okay, here solution, we know that the curve, we know that the sin x curve, isn't it? Yes. Sin x, y equal to sin x, 0, x dash, y dash. Okay, this is 1, this is minus 1, 0, pi by 2, pi 3 by 2 and so on. Okay, 3 by 2, 3 by 2 x. Okay, here minus pi by 2 minus pi. Okay, y equal to sin x, sin 0 0, sin pi by 2 1. Okay, sin pi 0, sin 3 by 2 minus 1. Okay, minus 1, sin 2 pi 0. Again the curve intercept the x axis at x equal to 2 pi. Okay, x equal to 2 pi. Here sin pi by minus pi by 2 minus 1 minus pi 0. Okay, this is the sine curve of sin x. Okay, here now draw the curve of cos x, y equal to cos x. Okay, y equal to cos x. Zero x dash, y dash. Okay, pi by 2, pi 3 by 2, 2 pi. Okay, here minus pi by 2, minus pi, minus 3 by 2, 1 minus 1. Here cos 0 1, cos 0 1, cos pi by 2 0, cos pi minus 1, cos 3 by 2 0. Okay, cos 2 pi plus 1. Okay, here minus pi by 2 is 0, minus pi is minus 1, minus 3 by 2 is 0, minus 2 pi is 1. Okay, 1. This is the cos x curve. Okay, curve of cos x. Here then the another one function 1 minus cos x. Okay, another one function f of x equal to 1 minus cos x in the interval 0 less than or equal to x less than or equal to pi. Okay, the minimum value, to find minimum value x equal to 0. Okay, x equal to 0, then f of 0 which is equal to 1 minus cos 0. Cos 0 is 1, 1 minus 1 is 0. To find maximum value. Okay, maximum value x equal to maximum limit pi. Here f of pi is equal to 1 minus cos pi. The value of cos pi is minus 1. Here 1 minus 1, minus of minus plus, that is 2. Okay, here draw the curve x dash x y dash r z. Okay, r z. Here this is pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, and so on. Minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi, and so on. This is 1. Okay, this is 1, this is 2, this is 3. Here minus 1, minus 2, minus 3. Okay, here in the first function x less than 0, we take the function sin x. X less than 0 means negative side, isn't it? X less than 0 means negative. Using sin x curve, okay, that is sin 0 0, sin pi by minus pi by 2 minus 1, sin minus pi 0, sin minus 3 by 2 plus 1, minus 2 pi 0. Okay. Next we take the another one function 1 minus cos x, 0 less than or equal to x less than or equal to pi. In this function the least value, that is the minimum value is 0, maximum value is 2, minimum value is 0. Substitute x equal to 0 is 0. Okay, substitute x equal to pi, means y equal to 2, y equal to 2. So connecting these points, this is the curve y equal to 1 minus cos x, 0 to pi. Okay, y equal to 1 minus cos x. Next draw the another one function cos x, x greater than pi. X greater than pi means 3 by 2, 2 pi, 5 by 2, like as. Okay, here using the cos curve, cos pi is minus 1, isn't it? Cos pi is minus 1. Pi is minus 1 and 3 by 2 is 0, 0, 2 pi is plus 1, 5 by 2 is 0, 3 pi is minus 1. Okay, 3 pi is minus 1, pi is minus 1. Okay, this is the cos x curve. Now draw the curve of the given function. Okay, this is the given function. Okay, the given function have some limits at a particular point, but only one point limit does not exist. In that point is x equal to pi. Okay, x equal to pi, because the curve break at x equal to pi means, therefore the given function of limit does not exist at x equal to pi, that is the x naught. Okay, that is the x naught. Okay, in statement, now the statement limit x approaches to pi, plus means x approaches to pi from right side. Okay, from right side, that is x greater than pi, isn't it? X greater than pi, f of x. Now choose the function cos x. Okay, choose the function cos x. Substitute x equal to pi into here, that is cos pi. The value of cos pi is minus 1. Okay, value of cos pi is minus 1. Okay, now find left one, limit x tends to pi minus f of x. It means x approaches pi from left side. Okay, we choose the function. This is the 1 minus cos x. Okay, this is 1 minus cos x. 1 minus cos x. This is sin x. This is cos x. Okay, this is cos x. Here choose the function 1 minus cos x. Limit x tends to pi minus the function 1 minus cos x. Now substitute x equal to pi into here, that is 1 minus cos pi. The value of cos pi is minus 1. 1 minus minus 1. Minus of minus plus 1, that value is 2. Here limit x approaches pi plus of f of x, which is not equal to limit x approaches pi minus f of x. Okay, therefore given function of limit, sum of limit does not exist at equal x not equal to pi. Okay, x not equal to pi. Next, exercise 9.1, question number 18. Sketch the graph of the function f that satisfies the given values. Second subdivision, f of minus 2 equal to 0. It means substitute x equal to minus 2. F of x approaches the value 0. That means y approaches the value 0. Okay. In the next one, x approaches 2, then y approaches 0. Okay. Limit x tends to x approaches minus 2, f of x equal to 0. Limit x approaches to f of x does not exist. Okay, does not exist. This is the given data. Using these data, draw the curve. Okay, draw the curve. Y dash x dash. This is origin. 1, 2, 3, minus 1, minus 2, minus 3, 1, 2, minus 1, minus 2. Okay, in the first one, substitute x equal to minus 2, then y approaches 0. X equal to minus 2. This is y equal to 0 means this point. Okay, this point. Then the another one, substitute x equal to 2, then y approaches 0. Substitute x equal to 0, x equal to 2, y approaches 0. Okay, then the next one, limit x approaches minus 2. X approaches minus 2, f of x equal to 0. Okay, f of x equal to 0. Then the next one, limit x approaches to, f of x does not exist. Okay, f of x does not exist means using hollow circle. Okay, using hollow circle, because f limit x approaches to on either side, f of x does not exist. Okay, does not exist means using hollow sphere. Okay, here minus 2 to 2 means, suppose the given function have the single straight line. Okay, suppose the given function have straight line. Okay, or suppose the given function quadratic equations, that is on curve means maybe this curve or this type or this type, any one, okay, any one curve or straight line, any one, but to limit x approaches to f of x does not exist. Does not exist means using hollow sphere, okay, using hollow circle, okay. Next question number 22. Evaluate limit x approaches 3 x square minus 9 divided by x minus 3 if it exists by finding f of 3 minus, it means x approaches 3 from the left side, okay, and f of 3 plus means x approaches 3 from the right side, okay. Now solution, the given function limit x approaches 3 x square minus 9 divided by x minus 3, okay. In the given function, the 9 can be written as 3 square, that is limit x approaches 3 x square minus 3 square divided by x minus 3. In the numerator, like as a square minus b square, so can be written as a minus b into a plus b, that is limit x approaches 3 x plus 3 into x minus 3 divided by x minus 3, okay. Here the factor x minus 3 are cancelled, then the final result limit x approaches 3 x plus 3, okay, x plus 3, okay. Here substitute x equal to 3, that is 3 plus 3 which is equal to 6, okay. Limits exists. Now find f of 3 minus, okay. To find f of 3 minus, okay. Here 3 minus and f of 3 plus, okay. Here f of 3 minus can be written as limit x approaches 3 minus f of x, that the function is x plus 3. Substitute x equal to 3 plus 3 which is equal to 6, okay. Now find f of 3 plus which is equal to limit x approaches 3 plus, then the function x plus 3. Substitute x equal to 3 into here 3 plus 3 which is equal to 6, okay. Both values are equal, and if and only if these values are equal, there is a unique real number in the given functions. Limit is 6, okay. Limit is 6. Question number 23. Verify the existence of limit x approaches 1 f of x, where f of x equal to absolute value function of x minus 1 divided by then the factor x minus 1 for x not equal to 1. It means x approaches 1 both either side, okay, that is approaches from right side and left side, okay. Otherwise 0 for x equal to 1, Here given the function absolute value function, that is x modulus of absolute value function x minus 1, okay. X minus 1 can be written as then the factor is x minus 1 is a factor, okay. X minus 1 is a factor means equal to 0, okay, x equal to 1, okay, x equal to 1. Here modulus of x minus 1 plus x minus 1 and minus x minus 1, okay, plus x minus 1 is x greater than 1, minus x minus 1 is x less than 1, okay, x less than 1. Suppose x equal to 1 means using the constant function 0, okay, okay. here to verify limit exits x approaches 1 f of x, limits exits or does not exist. Okay, solutions here in the first one, limit x approaches 1. Okay, x approaches 1 f of x x approaches 1 means x equal to 1 means then the constant function is 0. Limit x approaches 1 then the constant function is 0 which is equal to 0. Okay, the second one, limit x approaches 1 plus, okay, 1 plus f of x. Okay, 1 plus means approaches from right side. Okay, approaches from right side. Right side means x greater than 1, isn't it? X greater than 1. So using these functions, that is limit x approaches 1 plus means plus x minus 1 divided by x minus 1. Okay, here factor are cancelled, then the final result is 1. Okay, here limit x approaches 1 plus 1 which is equal to 1. Okay, which is equal to 1. Here in the third one, limit x approaches 1 minus f of x. 1 minus means x approaches 1 from the left side. So using this factor, that is limit x approaches 1 minus x minus 1 divided by x minus 1. Here factor x minus 1 are cancelled. Then the final result, limit x approaches 1 minus 1. Okay, minus 1 which is equal to minus 1 which is equal to minus 1. Here limit x approaches 1 plus f of x not equal to limit x approaches 1 minus f of x. Therefore, given function of limit is does not exist. Okay, does not exists.